Hello, friends. Welcome to the Nexus Podcast. I'm your host, James Dice. Each week, I fire questions at the leaders of the smart buildings industry to try to figure out where we're headed and how we can get there faster without all the marketing fluff. I'm pushing my learning to the limit, and I'm so glad to have you here following along. Before we get started, here's a quick note from our sponsor. Altura Associates is a mid-sized, mission-driven firm delivering impact and performance across the built environment in North America, and they're looking for the best in the industry to join their team. From designing and implementing corporate sustainability programs, to manipulating systems in the field to achieve optimized performance, to building the tools that support those project teams, Altura is committed to solving our world's macro-level problems through tangible projects today. If you're interested in working alongside passionate colleagues to make a lasting impact, reach out at careers@alturaassociates.com. That's careers@alturaassociates.com. This episode is a conversation with Tristam Coffin, co-founder at Effecterra. We started, as usual, with Tristam's background, which includes heavy experience in the grocery vertical, but our main focus here is in sustainable refrigerants. We've spent a long time covering how the buildings industry needs to decarbonize by electrifying heating systems using heat pumps, but we, on the podcast, and the industry as a whole, have overlooked the elephant in the room, which is that the global warming potential of refrigerants themselves is super, super high, and they contribute to climate change and every organization's progress towards net zero. So, as Tristam said, refrigerants are like Cinderella. They haven't been invited to the decarbonization ball, and this episode is about why they should be perhaps the first on that invite list. Hello, Tristam. Welcome to the show. Can you introduce yourself?
Yeah, I'd be happy to. Thanks for having me, James. Yeah, Tristam Coffin, co-founder and COO of Effecterra.
All right. And I'd love to get into Effecterra in just a second. Can you talk about and start with your background? How'd you get here?
Yeah, I'd be happy to. Like many of us have been focused on the environment for some time, in large part because I enjoy the great outdoors and all that it has to offer. So went into the environmental space, formal education, started in the sciences, and decided pretty quickly that I wanted to move more into the engineering end of things. So I had a fairly interesting degree where it was multidisciplinary, focused on engineering, natural sciences, as well as the business environment. So effectively environmental studies degree, but focused on the built environment end of things. Fast forward to post school, started looking for opportunities, landed with a transportation research center. So it's DOT grant funded, started doing research in renewable energy and sustainable transportation, and really got interested, but was kind of bored in the academic world and decided I wanted to get into the corporate space. So started tapping some resources and landed at Whole Foods Market in a sustainability manager position, otherwise known as green mission specialist at the time. And that started off a 12-year career. So I spent 4 years on the East Coast and remaining 8 on the West Coast. Ended my career with Whole Foods after spending 5 years in Director of Sustainability and Facilities role, overseeing engineering coordination, built environment sustainability and operations, facility management, environmental compliance. So wearing too many hats at any one time. Yeah, lots of changes in the corporate world, obviously, over the last several years between COVID and everything else going on. Took a long, hard look at opportunities after major restructure at Whole Foods that wasn't going to afford me the opportunity to continue doing what I was passionate about, which is really the sustainability work, and decided I was going to go off on my own and start an organization to help folks solve problem statements as it relates to the climate crisis that we're all facing into, and really do it in a way that is both collaborative, but also unique in the sense that focus on the pragmatic execution of the solutions themselves and not so much on just the strategy end of things. So like to say we're consultants, but at the end of the day, we're solutions providers.
Totally. And you and I met at Verge in San Jose a couple of weeks ago, in the fall of 2022, for those of you that are listening to this way after the fact. So that's when this conversation is happening. But I'd love to talk about Whole Foods for a second. I'm a major customer of Whole Foods. It's one of those things where I've just always it's been what I'd be willing to spend my money on, right? Is healthy food. But that's not what I want to ask you about. Obviously, I want to ask you about the grocery vertical specifically. So this podcast has done a lot about smart buildings and about decarbonizing buildings, but we haven't zeroed in on grocery, to my memory, in any single episode so far. So I thought that'd be a unique piece that we could add with this episode, just real quick. You're not focused on it fully, but what are your like reflections on your time there, 12 years? What are the kind of the keys to sustainable grocery and refrigerated retail, I guess, is a more insider term. And then what are the challenges with decarbonizing that particular space?
Yeah, it's a really good question. And I, like you, also gravitate towards Whole Foods and did early in my career with them and before my career with them, in large part because I really appreciate, the natural food industry, the organic food industry, and putting healthy foods into our body obviously translates to healthy foods being grown in the environment. And, we all know the kind of circular conversation that happens there in a very good sense. So, all that being said, like I said, I was attracted to it, had no idea what I was getting myself into, quite honestly, as it related to the grocery space and the challenges that we were going to face into over my 12-year career with Whole Foods and really the industry and in general. I think, to answer your question more specifically, the keys to sustainability in the grocery vertical are really interesting. The grocery is the second highest energy use intensity commercial building space in the US for one, but more generally in the world. Grocery looks a little bit different in places like Europe and so forth. So it varies in that, number 2 to 3 to 4 to 5 spot. But, second to really normally data centers, and it depends on how you're defining commercial building spaces, of course. So right off the bat, you're dealing with a very, very high EUI building. On top of that, you're dealing with refrigeration and refrigerants, which is a lesser known issue that we're going to, I know, dive into in a little bit more detail. And then you have the operational challenges that you need to face into too, whether it's waste input throughputs, specifically food waste in the grocery industry. So there's any number of focus areas that you could really start to hone your attention on. What was most exciting about it for me is that, it gave me a broad breadth of experience and knowledge in terms of what we focused on in regards to sustainability. And it really couldn't just be one issue, but had to constantly prioritize on kind of evolving scale where the greatest areas of opportunities were going to be. And you start looking at the building level versus holistically across the organization, it was going to differ. And certainly the priorities from the customers differ as well, right? So there are a lot of vocal customers in the grocery space. They have a lot of opinions, and rightfully so, right? It's where their food is coming from. So whether it relates to packaging or the comfort level of the building, et cetera. So yeah, there's just a lot to unpack in the grocery space. But what was most interesting to me is that refrigerants and refrigeration specifically were more often than not overlooked and seen as kind of just another dispensable asset. But anytime something went wrong with them, that was a whole nother conversation.
Mm-hmm. Yeah, totally. So we're going to get into the refrigeration side of things in a minute. In that grocery vertical, though, I'm wondering just a sense, your sense for being in that industry, because we talk about smart buildings. Smart buildings are really just a bunch of individual industries like grocery, office, multi-res, universities, K through 12, right? In that vertical, you spent a lot of time there. What are the kind of core smart building technologies that are important? And what's your sense of sort of the deployment or adoption of those technologies?
Yeah, it's a great question. Well, first of all, I use this example quite often, and the grocery space is challenged for a number of reasons, not the least of which is they operate on razor thin margins and extremely small operating budgets. So like a lot of industries, but I would say uniquely to grocery, they'll sweat assets for as long as they possibly can. And adoption of technology is oftentimes challenged in large part because of that razor thin margin and operating budget that they have to deal with. So, there's grocers out there that have grown through acquisition and so forth. And, they've taken years to get under a single POS system. Never mind, being able to deploy quote unquote smart building technologies.
Mm-hmm.
It relates to smart building technologies. I'd also argue that the grocery space probably has one of the highest amounts of disparate systems that they're utilizing out there, starting with refrigeration controls, HVAC controls, lighting controls, obviously the fire management systems, you name it. I mean, there's just any number of systems, and the list goes on. I'm just rattling off a few of them. But there's always been a desire in the grocery space to try to, I think, consolidate as much control as possible under one system. The challenge is that I think most in the grocery space have tried to do so under refrigeration-specific control devices or EMS systems. And that's challenging because the refrigeration controls do a very, very good job at what they're specifically intended to do, but that's not necessarily the case for other assets that they're meant to be controlling or monitoring within the building space. And I think we've seen that transition happen quite a bit here, and it's been an evolution over the last 5 to 10 years, in large part with the introduction of digital lighting controls and advanced HVAC controls. There's just no way that these refrigeration controllers are ever going to keep up. So that has led, I think, the industry to where most folks are in the smart building space, where they're looking for the proverbial single pane of glass, which I know you've talked quite a bit about on podcast and throughout throughout your career. And, everyone's aiming for it. Does it exist? Questionable, I think, at best. And you could speak to that far better than I can. But I think you're starting to see folks lean into at least EMIS systems or monitoring systems that are giving them more visibility to their assets. Now, whether they can control them or not is a big question mark. And I think will continue to be a big question mark, in large part because the refrigeration controls, which are really the brain of a grocery store, are so critically important to the operations. And anytime something goes wrong, it pretty much puts a redwood tree sized roadblock in place. And that's tough. And I think there's other elements too that need to be taken into account. And we can maybe get into a little bit more detail on this, but leak detection technologies, for example, have always been critical to the grocery space, but they've been somewhat unaffordable in some respects. And quite honestly, they haven't evolved much over the last several decades. So they don't really do, I think, what people think they're intended to do, which is address leaks immediately. They find leaks, they notify people, and
somebody's got to go.
Sometimes someone fixes it, I guess is the easiest way to put it. Mm-hmm. And then obviously food safety continuing to be an increasingly important element of operations and keeping people safe. Temperature monitoring and things along those lines have been critically important. And then, the age of the pandemic, obviously air quality, given can't not go to the grocery store, even though we're starting to see obviously delivery and last mile and so forth, but there's still, a fair amount of folks that aren't plugged into that and aren't going to, get food delivered to their house. They're going to go out and get it. And which means that, you have to be indoors at these spaces. So there's so much popping up. And like I said, I think the grocery industry is ripe for picking in terms of opportunity to address how we deploy these type of smart building technologies, but they've been slow to adopt in many instances.
Mm-hmm. Yeah, and the work I've done in grocery, I helped acquire or do some due diligence on a company they were thinking about acquiring in this space, and I was sort of blown away by doing all these different interviews with customers, and then talking about the same problems you see in other verticals with vendor lock, and those vendors are different vendors, but the same sort of patterns are playing out, which I found totally fascinating, specifically with refrigeration controls providers, the incumbents or the OEMs that have been around for decades. It's very similar to the building controls industry. I thought that was fascinating. Let's jump to Effecterra. So I'd love to hear a little bit more about the firm and the services and the kind of what you guys are up to and what sorts of clients you're serving.
Yeah, absolutely. Like I said before, we really set out to do something different. Obviously, having been on the owner-operator side for 12 years, have worked with a number of consultants and engineering firms, organizations, et cetera, and have nothing but the highest respect for everyone that I've ever worked with and those that I haven't as well. I think everyone that's working in this space has something to offer. I think for us, it was a matter of not becoming just another consultant that provided a strategy that unfortunately sits on an owner-operator shelf for several months, if not years, and collects dust, but really show up to the industry with some pragmatic solutions that we could begin to implement, ideally as quickly as possible, in large part because we truly believe that addressing the climate crisis at scale and pace is absolutely critical, and that's built into our mission statement. That being said, I've spent a lot of time in the industry and finding partners and organizations that are doing really great work. So I had the fortunate opportunity to co-found Effecterra with two partners, one of whom has about 37 years of experience in technology development. So that was really critically important to me, having that deep kind of technology background and expertise, which is unfortunately not something you find very often these days, because R&D seems to be getting slashed left and right within a lot of corporate organizations, at least. So he spent about a third of his career in aerospace engineering, about a third in energy, and about a third in refrigeration and HVAC. And that's how he and I got to know each other, and was sitting on the board of the North American Sustainable Refrigeration Council together. My other co-founder comes more out of the traditional MEPR consulting contracting space. And I say contracting because I think that's critically important. He also happens to be based in Europe, so it's a little bit of a different flavor over there than it is over here in the States. So really, we set out to, I would say, bridge oceans and try to bring technologies and solutions from across the globe to North America, where we feel like, give or take, maybe 10 years behind. And I know that's somewhat cliche, but it's the truth in some respects. So, and an approach to the industry with not a prescriptive set of services so much, to say that, hey, what's your problem statement? How can we help? And we had no idea what to expect in terms of how people were going to take that. More often than not, organizations are looking for you to tell them, here are your services, how can you use them? Instead, we were kind of going to people and saying, here is our experience, here's our expertise, here's the breadth of the knowledge of the team that we've built. And we're now a team of 13 and continuing to grow, mostly with technical background. But we've just hired our first policy expert, and we're extremely excited about her joining the team. So really trying to, I would say, address the climate crisis, and like I said, in a pragmatic way, with a breadth of experience that comes from multiple different backgrounds. And that's kind of come into focus in three ways. So we're doing technology development, and we're helping folks commercialize technologies that we believe are going to be an important part of the solution set for the climate crisis. And that's taken shape in a number of different ways, everything from energy to quote unquote smart buildings, through to refrigeration and HVAC, mostly in the advanced system side of things, which we'll dive into in a little bit more detail. We're agnostic, so we don't sell any technologies, and we really give third-party reviews similar to what you've been doing for some time in terms of what's the best. But we'll work with anyone who needs a helping hand in this particular space. The other piece is around more of the traditional consulting side of things, so working on GHG reduction efforts and working with, I would say, we thought we were going to be working with the tail of the dog, but we're also working with the dog. And what I mean by that is, we do believe all of the other companies that aren't the Fortune 500s that have aggressive climate commitments need to come along on this journey as well. So we're working with all of the above, but we've had the fortunate opportunity to also work with some of the big players, which is great because you learn a lot from what they've already started to commit to and have already started down the journey of accomplishing, which is critically important to be able to take those lessons learned and apply them to the smaller organizations that may just be starting out on their journey. But again, with a very pragmatic focus on the execution of those actual strategies. And then lastly is the services side of things, offering our technical expertise for things like commissioning oversight and helping with advanced HVACR system deployment, i.e. CO2 systems, for example. And that kind of comes full circle with some of the technology development work we're doing and some of the consulting work we're doing. So we're excited to be kicking off a project with Oak Ridge National Lab to develop a CO2 chiller heat pump. And that really stemmed from us seeing the demand from the consulting side, of there being a lack of solution to get closer to zero, and then saying, okay, I think we can work on this because we have the service expertise and we have the technology development expertise. And then going out and creating a collaborative consortium of team members, including Oak Ridge National Lab, to start working on an important and critical solution set that doesn't currently exist in North America. So that's a little bit about us. We're excited about our work and really excited about all the partnerships and collaboration that we've been able to work on in the short 2 years that we've been around, and hopefully many more to come.
Yeah, it sounds exciting. And that's super impressive, having come from a consulting background, super impressive to grow to 13 people in 2 years. That's awesome. With that context setting, kind of the background you're coming from, the expertise you're coming from, let's dive into our main sort of topic for this episode, which is sustainable refrigerants. And I'd hate to start with context setting again, but if you could, we're going a little bit level deeper here into context setting, but maybe just to start with why sustainable refrigerants are important.
Yeah.
Because let me just set a little bit more context, because I think if you're coming into this from listening to all of our past episodes, you might think, hey, we have to electrify everything to solve climate change, and we have to convert everything to heat pumps. If anything, refrigeration is what we need, right? We need more refrigeration, right, to make heat pumps happen. And so what I'd like to do with this conversation is sort of widen people's gaze a little bit and sort of get into, okay, yes, but this type of refrigeration. So with that, would love to hear you sort of set the stage.
Yeah, no, that's great. And I think there's two contextual pieces that we can dive into. It's the history, right, which I think is critically important to outline. And it's also to the point that you were just making, why refrigerants are important today and why they're going to become even more important. And I think with that being said, that piece is somewhat simple, and I'll start with I guess a little bit of an anecdote. But you can electrify your way out of natural gas usage, right? You can move to renewable energy or 24/7 carbon-free energy to get yourself out of the scope 2 emissions challenge that you're facing into. And you can electrify your fleets. Effectively, like electrification and move to 24/7 carbon-free energy will get your organization generally close. There's one outstanding item that is not going to be something that you can just easily kind of flip the switch on, so to say, and that happens to be refrigerants. And because of that, and also because of what you just alluded to as a result of the increase of heat pump technologies that utilize refrigerants that are going to be the main solution for electrifying heating specifically for both domestic hot water and space heating, is going to increase the amount of refrigerants that are going to be utilized. That's one piece. We'll come back to that. The history piece, I think, is really interesting. We've kind of been going through this evolution over the last several decades of, starting with quote unquote natural refrigerants, which I know we're going to talk a little bit more about, I hope, as part of the solution set, which were the original refrigerants. We moved to synthetic refrigerants, specifically CFCs, that were introduced into the space several decades ago, and those are the original synthetics. We realized over time that they were causing a hole in the ozone layer effectively. So the Montreal Protocol comes into place. And that Montreal Protocol, which is a global treaty, said we need to address these CFCs and HCFCs effectively, which were the replacements for the CFC. So we started to address the call it synthetic refrigerant issues that were focused on what they call ozone depletion potential, or ODS, which is ozone depleting substances. And you fast forward, and today to where we're at today, we've effectively started to phase out all of those refrigerants. They're still in use, so they're not gone. Still very much in use, including the earlier CFCs, but HCFCs in particular, to HFCs, which are the lion's share of what's being deployed out there today and is already in operation and many of the refrigeration, HVAC, and other heat pump type technologies that exist out there. And the reason there's such a challenge and such an issue is because they have an extremely high global warming potential. So this is the core of what you were asking in your question is, if you have carbon dioxide that has a global warming potential or GWP of 1, your common HFC refrigerants are going to have a global warming potential of anywhere between 2,000 and 4,000. So, which means that their impacts on global warming is 4,000 times or 2,000 times, depending on the type of refrigerant, more potent than carbon dioxide, which is the common conversation that we're using as the baseline, right? It's the CO2 equivalency that we have to concern ourselves with. And it's why methane, for example, is getting a lot of attention right now too, because these are not only are they that much more potent, but their lifespan is also different. So you probably heard the term short-lived climate pollutants, right? Their impact is very, very potent and very, very impactful in a shorter period of time.
And basically, I hate that I don't know if I have to point this out to people, but I feel like I should. So when I moved into my house that I currently live in, turned on the air conditioner for the first time, didn't work, blowing out hot air. Tech comes out and he's like, you're supposed to have 7 pounds of refrigerant and you only have 2.5. And I was like, okay, cool. Where'd the other 5.5 go? And that's the main way that this happens, right? Is it's a gas and it leaks. As soon as you have a hole, it leaks out, right? That's the main way that these emissions happen?
Yeah, it's a really good question. So you have to look at the life cycle of it, but generally speaking, yes, the operational element of the system that you're deploying, whether it's your home AC unit, whether it's your home refrigerator, whether it's a grocery refrigerator, whether it's, commercial building that's operating a chiller or a packaged rooftop unit. During the operation of those systems, the gas is going to leak. It's just, there's no way around it, whether it's because a mechanic does something incorrectly, whether it's because it's a manufacturing default, or just because lightning strikes. The reality is that these gases are somehow throughout the operation, more likely than not, going to find their way into the atmosphere. But there's also the beginning of life, right? So when you're charging a system, either at the factory or in the field, when I say charging, it means effectively putting the gas into the operating system or the pre-operating system. And then there's the end of life. And I think the end of life, and there's some statistics out there that say 90% of refrigerant emissions occur at end of life. And that 90% number is obviously not industry specific. It's a global stat that exists out there. And largely because what happens when people rip things out? What happens when a building is demolished, right? If not properly addressed, demolition comes in, they start removing everything, and even if they're doing it systematically, more often than not, if they're not trained to properly recover the refrigerant gas within these systems, it's going to leak. And, that's less common in the commercial and industrial space. But think about you as a homeowner, right? If you didn't have the background that you do, right? If you're, let's say, for instance, you're like, you moved into your house and you just needed a new AC unit. Maybe you decide you're going to rip the old one out. And there's a lot of people that are doing it themselves out there. They rip it out, throw their AC unit to the curb and hope for the best. But can almost guarantee that, even though there are regulations out there in some places in the world, not all, to address that gas is just ending up in the atmosphere, almost hands down. So it's an issue that we need to address throughout the life cycle. And there's a recent report issued by the NRDC, IGSD, and EIA focused on life cycle refrigerant management. And, by their estimations, it's a 90 billion ton opportunity by the end of the century to address. And we'll get into the details of those numbers and so forth here. But it's critically important to focus on reducing the leaks wherever we possibly can, and really honestly getting beyond leakage, which is another topic I'd love to unpack with you.
Cool. All right. So basically, if I can repeat all that back to you, refrigerants are extremely potent. They should be part of organizations' scope 1 reporting, potentially even scope 3, maybe if they are getting rid of them afterwards. And then as we electrify the planet, as we electrify buildings, they're only becoming more and more important, right? That's the general context. Another piece of context that I was wondering about, I read about the US AIM Act. Can you talk about what that means? Is that relevant here?
Yeah, absolutely. So effectively, the Montreal Protocol was the global treaty that started to address, call it ozone depletion or depleting substances, or ODP refrigerants. Fast forward, the Kigali Amendment came out. I'll get my math wrong here, but after the Montreal Protocol, about 15, 18 years, I don't know, a couple decades later, and the whole idea behind the Kigali Amendment to the Montreal Protocol was to begin to address the HFCs. So hydrofluorocarbons, which are the high GWP refrigerants. They don't have the ozone depletion potential, but they do have that high GWP. So the Kigali Amendment to the Montreal Protocol is the global treaty that addresses it. U.S. AIM Act was effectively aligning the U.S. regulation with the Kigali Amendment to address HFC refrigerants. So like there was a phase down with the ozone depleting substances, there is now a phase down on the high global warming potential refrigerants, specifically HFCs. So those HFCs are now already in the midst of the phase down. There was a slight drop in terms of allocation in 2022, 2023, and there will be a much larger drop in 2024, and then so on throughout the next decade and a half or so, whereby HFC refrigerants will eventually be phased out. We've seen similar regulations in Europe under the F-gas regulation, and it's a very good thing. The challenge is what next effectively, and that's a conversation that we'll come on to here in just a moment. But my argument is that we need to think beyond the next interim solution, and we need to be thinking further out to the final solution. And when I say further out, that solution needs to exist today, and in some instances it does. In other instances, it doesn't, but we need to be thinking about it and we need to be working on it.
Totally. Yeah, we'll get to that, I hope. Let's start though with, if I'm looking at this from a building owner standpoint, and because we've done, 14 different podcasts on decarbonization this year. in 2022 alone. We did even more in 2021. So we're on this march, right? And I haven't heard, we had several building owners on the podcast. You know, I'm not going to call them out because I'm going to say that they're not thinking about this, but I haven't heard anyone say, refrigerants are part of our scope 1 inventory today and they're 10% of the, whatever, right? And I haven't heard anyone say, we're going to get rid of scope 1 by fixing, our heating and electrifying it, but also fixing managing refrigerant. I haven't heard anybody say that one time. So
that makes me sad. You know that, James, right?
Well, you're part of the solution here, but so how many companies are actually doing that, including it in their inventory today? Because I feel like most are just saying, okay, what's my natural gas or, direct consumption from my utility bills?
Yeah. It's a great question. And unfortunately, most folks, you're not alone in that regard. And most folks that you've spoken with and most folks in the industry, consider this a niche area. I was having a conversation with someone that hosts a very large zero event annually. And, just said, it'd be great to highlight refrigerants as part of that. And, they just honestly said to me, it feels like a very niche issue. And I said, yeah, that's part of the problem is everyone thinks that it's a niche issue, but it isn't a niche issue. We're dealing with refrigerants in almost every building space out there. I think the challenge is the supermarket industry, for example, has been focusing on it for many years because it is a very concentrated amount of refrigerant gas in these refrigeration systems. However, if you go to any large commercial building space where, they're just cooling and heating the space alone, there's still likely upwards to thousands, if not several hundred pounds of refrigerant within these buildings and high GWP refrigerants, as we were talking about before. So it's an issue that everyone's facing into. And I think the other big thing there is that it's growing not only for the fact that the solutions that we're deploying for things like electrification and decarbonization are including it, but it's going to grow because it's going to become the last standing scope 1 emission that you have to deal with. And like you said, also scope 3, arguably, depending on who's managing it for you, et cetera. But generally speaking, focusing on the scope 1 aspect of refrigerants. So, but I think the challenge and why we don't hear about it as often as we should is because it's not as tangible, right? I think it's harder to measure. There's a lot of human root and error in terms of tracking it. Regulation has been very focused on, as I mentioned, ozone depletion substances for some time now, and honestly only tracking those systems with 50 pounds of refrigerant and above. And as we were talking about before, or as I was just alluding to, those, especially in a space where packaged rooftop units are dominating cooling in North America, specifically in the US, packaged rooftop units are normally like around the 50-pound limit, but they're not always approaching it. So as we've continued to create more distributed cooling systems, there hasn't been as much attention on those distributed systems because compliance hasn't focused on them. So that is the other big issue that we're facing into is there is not nearly as much data out there as necessary to determine what the magnitude of this issue is. A lot of it has been modeled. It's not even actually been measured. So, and that's in large part because the focus in the US and a lot of the other parts of the world where there is regulation has been on systems with 50 pounds or somewhere close to that range of ozone depleting substances versus all of your systems that contain refrigerants with any type of refrigerant in it. And with that being said, we have very, very, like I said, little empirical data to say, here's the order of magnitude that we're facing into. So we have an idea and we can, model the numbers and so forth. And that's where some of the statistics that I've thrown out earlier and will continue to rattle off as we continue talking come from. But I'd argue that the challenge is even bigger than we expect.
Mm-hmm. Fascinating. Yeah. So if I think about my home system, I think it's 3 tons. It's got 7 pounds. So it could have, so 50 pound would be, still a pretty small unit.
Yep.
Yeah. Okay. I think it's a good time to just sort of introduce, low or sustainable refrigerants themselves. So you mentioned, I think we've talked about low GWP refrigerants, low GHG refrigerants, natural refrigerants, sustainable refrigerants. Can you kind of just sort of define like what are these different types of refrigerants?
Yeah, happy to. So there's two, call it schools of thought. There's a synthetic refrigerant, and then there's natural refrigerants. And natural refrigerants are somewhat misleading, I would say, just by their terminology alone. Say natural refrigerants, it's not that they're necessarily, pulled out of the air and you can just use them. So for example, CO2, not coming from, carbon capture or anything along those lines. It's normally the byproduct of, specific industries. That's where that CO2 is coming from. So some folks are beginning to use the term nature identical. In other words, they appear on the periodic table, so they're naturally occurring, but they're not necessarily quote unquote natural refrigerants. And I think that statement becomes more matter of fact when you start talking about hydrocarbons as a refrigerant, right? So things like propane or R290 is the ASHRAE number provided to refrigerant grade propane. And people are like, wait a second, isn't propane part of the problem? Isn't carbon dioxide part of the problem? And the reality is yes, they are part of the problem, but when used as a refrigerant, they have a GWP of anywhere between 1 and 3. And as we talked about before, the GWP of most synthetic refrigerants that are on the market today are well above, the 1,000 mark, as we discussed previously. And even the interim solutions that are coming to market, and this is an important note. So there's a lot of terms floating around out there. So HFOs are the new, call it not brand, they're the new synthetic refrigerants that are coming to market. And they already are on market in some respects. The F in there is the important piece. They're fluorinated gases, effectively. And yes, the new fluorinated gases are having a lower GWP. In most cases, they're moderate. So R32, for example, which we believe is going to be an important part of the solution set, but it still has a GWP of above 600. I think it's 650 or approximately 650, remembering it off the top of my head. But that's also using a 100-year value, which is something we can get into here in just a minute. So 100-year GWP value is measuring the impact of that gas over 100 years. But remember, these are short-lived climate pollutants. So if you use a 20-year value, and I think if I remember correctly, the average life of most synthetic refrigerants is about 21 years, if I'm not mistaken. So the 20-year value is actually more representative of the impact of these gases in the atmosphere and on the climate. That being said, the values of those particular gases actually increase. So R32 actually goes above, I think it ends up being like 800 or 900 or even above 1,000, if I'm not mistaken. So that plays a really interesting part in the conversation because regulation is saying we need to get to 750, at least as an interim step. And a lot of the OEMs, chemical manufacturers, et cetera, are aiming for that. And they're creating these interim solutions. When I say interim, I argue they're interim because if the end goal is as close to zero as possible, there's no way that these aren't interim solutions. So therefore, we're running into this kind of next phase of the challenge as we went from ozone depleting substances to high GWP, HFCs, to now we're looking at HFOs, which are interim solution, some of which are also flammable. So you've probably heard folks refer to, or maybe you've heard, or some of your audience has heard folks refer to them as A2Ls. So the A2Ls are a cation of the refrigerant that means that they're slightly flammable. A3s, for example, are highly flammable. So for example, R290 is an A3 refrigerant, highly flammable refrigerant. A2Ls, slightly flammable refrigerants. Those are coming to market. And a lot of folks are looking at the A2Ls, which are in most cases HFOs, as the solution. And it's not that they're not going to be a part of the solution, but again, as I mentioned before, in my mind, we need to leapfrog the next interim step, and we really need to go as close to zero as possible. The reality is natural refrigerants exist today. They're being deployed in a number of different solutions and applications. Do they come with their challenges? Absolutely. I just mentioned R290, for example, is highly flammable, so additional safety measures, and it's not going to be utilized in every application, especially in high charge amounts. CO2 has very high operating pressures, but it is a very manageable and a very efficient and very effective refrigerant with a GWP of 1. And it is becoming more common in more and more applications. So refrigeration, for example, there is no reason why commercial refrigeration in my opinion, should be using anything other than CO2 at this point. Why? Because it's going to get you as close to zero as possible. And the supplemental technologies that have come into play, better control algorithms, liquid and gas ejectors, adiabatic gas cooling, the list goes on. And there's other technologies like pressure exchange devices, and et cetera, that we've had the fortunate opportunity to work on that are going to make CO2 even more effective in terms of its deployment within these different applications. Is that true for packaged rooftop units? No. And therein lies the challenge that we're heading into. The US, unfortunately, has an addiction to low cost, very efficient packaged rooftop units for cooling normally commercial buildings, and really any buildings for that matter. Those high pressure systems do not have an alternative right now. In other words, a lot of the gases, the low GWP synthetic gases that are coming to market operate in low pressure environments. So a lot of the decks that have a GWP between 1 and 3 will work great in low to medium pressure chillers, but they're not going to work well on these high pressure packaged rooftop units, for example. And the same is true for the naturals. So there's, like I said, two different conversations that we're coming onto here. One is solutions exist and we need to be deploying them in the applications today where they exist. And I would argue natural refrigerants are a very good solution. Are they the sole answer? No, I would never argue that they're the sole answer, but they definitely need to be a bigger part of the solution today. The other is we need to face into the technical challenges that we're facing to address the other applications. And it may require a paradigm shift. We may just have to say, you know what, if packaged rooftop units are not going to get to a place where they need to get to because of the technology issues that we're facing into, then we may have to look to go back to more centralized system architectures so that we can deploy better solutions that are coming to market at the scale and pace we need them to.
Got it. Wow. That's such a great overview. Let's pause here for one more quick word from our sponsor, and then we'll get back to the show. Now, I know many of you enjoyed the virtual Smart Buildings Exchange conference in August. The team behind that conference is the Smart Buildings Center Education Program, a 501c3 nonprofit organization that believes a smarter use of technology and practices in the built environment, particularly as they relate to building operations and management, will enable a cleaner, healthier, and more productive future. The Smart Buildings Center seeks to establish thought leadership for smart technologies and practices within the built environment and pursues its objective through the following pillars of activity. First, they deliver training programs to educate the building workforce of the future. Second, they enable industry-leading demonstration projects. And finally, they connect the industry through hosting and participating in events like the Smart Buildings Exchange Conference. So check out their body of work on the essential role of smarter buildings in the clean energy transition at the link in the show notes. And when you get in touch, tell them Nexus Labs sent you. So my next question is around, I want to get the solutions. I want to make sure we have time for kind of how you guys help your clients sort of work through this, right? Well, when I was watching you at Verge, you sat on a great panel, really great panelists. You were awesome on it. Some questions came from the audience around challenges to natural refrigerants, challenges to low GWP refrigerants coming from the HVAC OEMs, right? The manufacturers of packaged rooftop units, chillers, et cetera, heat pumps, right? Can you just kind of summarize what's going on there? Because what I found interesting was these are the same manufacturers that are touting their systems as energy saving and decarbonizing and green. And at the same time, it felt a little bit like what was happening is they're delaying the progress that's happening from this, on this transition to more sustainable refrigerants.
Look, I'll start by saying I don't think anyone out there, including even the chemical manufacturers that are working on these synthetic refrigerants, have any sort of ill intent specifically, right? Like they're focused on operating their business and the way that they need to operate their business to remain in compliance and try to provide what they believe is the necessary next generation of solution. The same thing that we were kind of just talking about is there's not enough recognition of the actual issue that we're facing into. And that's why education and conversations like these are critically important. Starting there is the OEMs specifically that are manufacturing the majority of the HVAC equipment that's being deployed in the US today are focused on energy efficiency because that's what they've been told they need to focus on. We, as an industry collectively, need to shift the conversation from specifically focusing on energy efficiency to starting to look at, well, one of the industry terms is total equivalent warming impact, but I would just call it total life cycle carbon impact of not only the equipment and its operations from an energy perspective, but the direct emissions associated with the refrigerants, of course. And then if you really want to get into it, call it the embodied carbon of the materials that are being used to obviously create these systems. That is hard to swallow, right?
Yeah.
Especially when you're not being told to do that and when the market is not moving you in that direction. There's also the technology challenge that I just mentioned, right? Like today, the OEMs do not necessarily see a clear line of sight to be able to produce what they're producing in terms of a similar application utilizing a better refrigerant. Let's put it that way. And that is a true issue that needs to be addressed. And that's why I was saying, like, can we work on it? Can we put more R&D dollars into finding a high pressure gas that can work in a packaged rooftop unit that it comes closer to a GWP of 1 or even 0 for that matter? Yes, I believe we can. And I believe there are companies globally, including ours, that are thinking about that and are starting to work on it. But it is going to have its technology challenges, and we won't get into the details of that today. And quite honestly, I'm not even as well versed on it as I probably could be. There are plenty of folks out there that are in the R&D labs trying to figure out what the next best solution is, and I'm certainly not one of them. We're working with many of them, but so I don't want to speak too much out of turn here. But there is a technology challenge, and we can't ignore it. But that being said, there are solutions that can be deployed, and it will require paradigm shift, and that paradigm shift does require a change in thinking about how the architectures are utilized. And what I mean by that is, I think the grocery industry specifically is really facing into an interesting opportunity whereby you could start to utilize the refrigeration system more effectively, not just from a heat reclaim perspective to use the waste heat off the refrigeration systems for heating and cooling purposes, but start to leverage the natural refrigeration systems, of which CO2 is a hugely effective gas, especially from a waste heat perspective, to start to utilize that for the heating and cooling of the building space as well. And, I come obviously having spent a lot of time in the grocery industry, but that similar application can be deployed in chiller systems and other systems or other like systems, across other building sectors and so forth. But again, it really is going to require a shift in everyone's attitude towards how we approach heating and cooling in building spaces. And the other, I think, important piece there is because refrigerants aren't being tracked, and again, that order of magnitude in terms of what their impact is going to be and the lack of awareness is, there's no compliance pressure on the OEM space to start to think about this, even though there's a phase down coming into effect as we talked about under the AIM Act, but they already have their interim solution. So most of them are going to move to these moderate GWP refrigerants. The roadmap for all the OEMs right now is to get below effectively 750 in terms of GWP. But 750 is still a very high number, right? As compared to 1 or 0. And then because of the lack of awareness, the market's not pushing them either, right? Because most climate initiatives at organizations and at most of the state level or even globally are not saying, hey, you need to address refrigerants as much as you are addressing energy efficiency. And those are kind of the three or four big challenges that we're up against. And that's why the awareness conversation is critically important. And I think you heard me mention REEF, which is a forum that we kicked off actually at Verge called the Refrigerant Emissions Elimination Forum. And the whole idea there was to really kick this conversation into gear and start to raise an awareness amongst a cross-stakeholder group of owners, of operators, of subject matter experts, eventually moving into the conversation with the OEMs, with the manufacturers of the components, start to say, hey, this is an issue. We are paying attention to it. And if we don't start to address it now, there's no way we're going to hit our climate objectives, in the next decade and beyond, because this technology issue is not going to be solved overnight is the big deal. And it may not be solved within the decade, but if we don't start now, it's definitely not going to be solved within.
Totally. Let's jump into solutions. And maybe just starting a little bit more high level, and maybe we can dive in if it makes sense. But I think about the whole marketplace as a whole bunch of existing buildings and then new buildings coming online that are less in quantity, but still important, right? Um, so can you talk about those two categories of buildings? Where might an asset owner or a developer start to think about this, and what are the solutions they can sort of implement for getting a wrangle on these emissions?
Yeah, it's awesome question. And it's going to sound super cliche, and I'm sure people have said it a million times before, but you can't manage
Can't
what you
imagine
don't
you
measure.
don't measure.
Yep. And yeah, see, you took the words right out of my mouth. But it's true. It's really true. And in this case, it's very true. And I think the challenge that I alluded to earlier with refrigerants is that they're a lot harder to measure than natural gas or electricity use because they're not running through a meter. Let's put it that way. So, dive a little bit into the weeds without going into too much detail, because I know we want to focus on the solutions. Is, tracking refrigerant gases requires someone going out and, first off, understanding what was in the system to begin with. Secondly, how much gas they're putting into the system if there is a leak, and then following that throughout the life cycle of that piece of equipment, right? So even if you're doing it perfectly from day one to, the last day of operation, recovery, and ideally destruction of that refrigerant gas, you probably still missed a portion. I don't know what the percentage may be, but the reality is it's not happening perfectly. It's happening less than perfectly. But the starting point is taking an inventory, getting out there, understanding every asset that has a single drop of refrigerant in it, arguably, because every drop of refrigerant in my mind is important. And I think that's the message that we want to get out there. Creating that inventory, first and foremost, and then starting to track the service events associated with those assets. So understanding when gas exits the system, when gas is put back in the system, calculating your leak rates associated with each of those individual assets. And again, not the bare minimum, so not the 50-pound and above units with ozone depleting substances in them, but every unit with any drop of refrigerant in it. And again, that's a tremendous undertaking in large part because there are thousands of assets in any given, commercial building, let's put it that way. Everything from under-counter refrigerators to, split units that are cooling computer rooms to all 30 package rooftop units up there, and and maybe a chiller or rack-based system that's cooling some sort of pharmaceuticals or groceries or whatever the case may be. The list goes on and on and on. So it's not an easy undertaking, and then measuring that gas in the first place. And there's three methodologies to go about measuring it. One is nameplate, which you hope for the best that you can actually take the manufacturer charge off the nameplate if it's not, worn out, weathered out, whatever the case may be. The other is calculation. So you effectively measure the piping or estimate the measurement of the piping and the components within the system, and then go through a calculation methodology to determine how much gas may be in the system. That's also fairly challenged. The best, but the most intensive, is actually taking the gas out, measuring it, weighing it, and putting it back in. Anytime you open up a system, you also turn it into a potential leak potential event. So there's all these challenges. All that being said, is starting point is beginning to create an inventory, measuring the amount of gas, or what we like to refer to as the entrained carbon of the systems, and then the total assets all together and combined to understand what your building's entrained carbon looks like.
Okay.
And then you got to keep tracking it going forward. So it's not like you're done, right? you give up. But from there, it's about starting to understand how you can avoid the refrigerant gases, from exiting those systems throughout the remainder of their life cycle, as well as at end of life. And we can come on to the end of life solutions here in just a moment. But then it's also thinking about how you can start to look to alternatives. So for those of you who haven't read Project Drawdown, for any number of reasons, go read it, go look it up. In 2017, they published the first report, and the number one climate mitigation solution was refrigerants. And I think the joke was, who's going to write that press release, right? For the very reason that we've talked about, people's eyes tend to glaze over when it comes to talking about refrigerants. They've since published a number of other reports. They've actually split out refrigerants into two categories or two solutions because it's focused on solutions. Number one is refrigerant management. Number 2 is alternative refrigerants. You add them two together, I think they're still in the number 1 or number 2 spot in terms of climate mitigation opportunities. But so we're talking about refrigerant management as one, but then once you understand how you manage your refrigerants, you then need to understand how you start to move to alternatives. So starting to take out those high impact refrigerants or high GWP refrigerants, and in many cases where ozone depletion substances are still in employment, take those out, which as I may have not mentioned previously, they also have a very high GWP. So it's not like they just have ozone depletion potential. They also actually have a high GWP as well. So removing those from the equation is critically important and moving to alternatives. But it's also not as simple as that, because you have to look at it strategically in large part, because if an interim solution isn't going to get you the whole way and you're going to put a 20 to 30 year asset into a building with a moderate GWP refrigerant, you may actually want to wait. So it may be this kind of hurry up and wait scenario. So it's really a matter of kind of measuring the different variables and impacts that are associated with the overall building use, asset use, life cycle, leases, everything that, you talk about on here quite frequently, and the different variables and factors that play into decision making when you start to think about refrigerants and how you're going to potentially move to those alternative solutions. But yeah, number 1, refrigerant management. Number 2, alternative refrigerants. Sounds really simple, but there's a lot more to it.
Absolutely. Before you move on to end of life, I wanted to ask you around finding leaks. So is there technology out there that allows these systems to be monitored? So the analogy I would use is when we have, data coming off an HVAC system, we might look for chilled water leaking, or we might look for hot water leaking, or we might look for different ways in which that system is wasting energy. But there's not necessarily like a sensor that's producing refrigerant leaks, right? There's pressure sensors sometimes, but those aren't necessarily always pulled into analytics software. They're not necessarily pulled into a building automation system.
Yeah.
So what's sort of the state of the technology for using analytics to find these leaks?
Yeah, it's a fantastic question. And I think there are a number of companies out there, including ours, that are thinking about this and how we move from effectively what we call a diagnostic to a prognostic. And maybe not all the companies that I just referred to are thinking about that, but it's something that I think the industry needs to start thinking about, and something that we've been working on and thinking about ourselves. The reality today is, depending on the system application, so whether it's a packaged RTU or a, refrigeration system, the level of sophistication in terms of the controls and what's being monitored, measured, and controlled is going to be very different, right? And that, and a lot of that depends on obviously the age of the system as well. There are other subsystems, i.e. leak detection, or what they call automatic leak detection systems that are out there also. I think there's a very large misunderstanding, and I'll address both points here in just a minute. There's a large misunderstanding on what automatic leak detection actually does. Automatic leak detection is effectively, in the simplest of terms, and there's different types of technologies, but in the simplest format, they are identifying leaks and sending out a notification that a leak has been sensed. And there's different trigger rates, right, in terms of parts per million that they're sensing. Remember that in almost all instances where refrigerants are being utilized, there's air movement, right? So whether it's an HVAC system or refrigeration system, there's a lot of air moving around, which means that even the best of these systems being deployed, more often than not, aren't going to sense the leak to the extent that they need to. And even if they are able to, again, you're only identifying that there was a leak, not that you're actually like capturing it and fixing it, or for that matter, measuring the amount of gas that's left the system. So it's not like you were just getting at like a meter or anything along those lines that's telling you how much gas has actually exited the operating refrigeration cycle. So now there are a number of technologies that are starting to be deployed to use algorithms based on deployed technologies, sensors, et cetera, that are beginning to identify how, can over a period of time start to estimate how much gas is in the system, and also start to look at degradation in performance, for example, whereby you can begin to identify when a leak may occur. And that's what I was getting to in terms of starting to look at prognostics versus diagnostics, is if you can start to build off of the diagnostic technologies that exist out there today, I think we can get to a point where we can ideally, and it depends on the system and application, but I think in my mind, there is a technology solution that we can get to, or technology solutions, that we can get to whereby we can use the available solutions out there today and build off of them to hopefully identify leaks or at least degradation or anomalies within these operating systems before a catastrophic or even less than catastrophic event occurs whereby refrigerant gas may exit the system. We're not there yet. I'm hoping we're getting there soon.
I was going to say that this is an area where I feel like the designers of automation systems can do a better job if they knew that what we were going to do with this data, right? So a lot of times the data that we would need to do the diagnostic that you just said is in a chiller or it is in a rooftop unit, but we're not actually pulling that data out into a place where it could be used. It's just being used in the local controller, being used by the technician that's going to plug their laptop into that thing, but it's not actually able to be used in the fault detection diagnostics application most of the time. And so it's more about specifying, hey, here's the exact data we want out of this machine. I feel like we can do a better job there.
Oh, 100%. By our estimations, if you did it at the factory and you did it up front, it would probably be, a matter of adding in a couple $100 worth of additional sensors and data points that you need to collect in order to start to get to a point where we were just discussing.
Totally. How about end of life then? Maybe real quick, because most of the people that are listening to this are not going to care about this, but what happens after it leaves the building?
Yeah. Well, so end of life, if you're actually recovering the refrigerants, which is the ideal scenario is, if you are able to properly address refrigerants at end of life, you would recover. And there's a few different options. There's reclaiming them, which effectively means that you're cleaning them and they can be used in other applications. You can recycle them by law. You can technically recycle them in another asset within your portfolio that utilizes that same refrigerant. But ideally, I think, especially with the refrigerants that are out there today, really you're recovering them and destroying them in the most efficient way possible based on, there's a few different destruction methodologies. I'll be the first to tell you, I'm not an expert in the destruction methodologies. There's plenty of folks out there, well, not plenty, but there's a handful of folks out there that can go into more detail on the actual destruction methodology, but they are removing I think it's upwards to 99% of the potential impact overall. And the great thing about that now is that there's plenty of arguments to be made about carbon offsets and verified carbon credits and things along those lines. But there are a number of methodologies out there today to actually certify the destruction of refrigerants, high GWP refrigerants specifically for verified carbon credits, which I'd argue if you're going out and buying them anyhow, hopefully as the last resort in terms of your strategy, that this is a perfect opportunity to utilize the destruction of an already challenged GHG to get you closer to your goals.
Fascinating. Okay, let's close out. My last question is around training and upskilling. So, you educated 30 people in the room at Verge. I'm sure you're doing that all the time, but it feels like there's so many different stakeholders here that need to understand that this is even a thing, which is why I wanted to have you on the show, first of all. But even our audience is not going to take this and go give it to all the HVAC techs out there and all the HVAC service contractors that are doing all of these, service calls for low refrigerant, et cetera, et cetera, et cetera. So what has to happen for us to sort of train and sort of upskill everyone to get to where we're making the right decisions and actions here?
Yeah, it's a really good question. There's different levels of education, right? It's one, getting people to understand the issue that we're facing into. And we've been trying to do that in creative ways by calling, refrigerants the ugly duckling of the GHG, equation, and also calling it, the Cinderella of the carbon conversation because, they haven't been invited to the ball yet. And so, there's just generally that wider kind of hey, how do we figure out how to get the attention to this? And again, really appreciate you for having me on today to chat about this lesser known subject. And then you're absolutely right. Then there's call it the technician base and the necessity for folks that are working on these systems to have a better understanding of the critical importance of the work that they do. Fortunately, we're facing into a really big challenge right now, not just the climate crisis, but the people that are going to be a part of the solution. The average age of an HVAC refrigeration technician is 55 years old, the last stat I saw, which means that people are retiring out of this space. The good news there is that there is attention to this and the industry is recognizing it. Question is whether or not they can recognize it at the scale and pace that is necessary. The other exciting piece is a lot of these advanced HVACR technologies that I've been alluding to or referring to, especially naturals and CO2 specifically, require more electronic components and controls and so forth. And I mean, a lot of people oftentimes use this example, but I'll use it as cliche as it may be. But we really need to move in the direction of where the automotive industry has moved, right? As it relates to these systems whereby, there was actually an article that came out from Emerson, I think earlier today, talking about the standardization of these equipment components. And standardization is going to be critically important, but as is being able to run diagnostics on these systems so that, the next kids that are coming into this generation, what do they want to be able to do? They want to be able to solve the issue on their phone, not have to go and turn a wrench, at a grocery store or, on top of a 30-story building, commercial building or something along those lines, right? They want to be at least able to see how the system is operating from afar, ideally on their smart device, and begin to hopefully, either solve the issue there or at least be able to diagnose it and make the longer term fix more efficient or be able to accomplish it more effectively. We're not quite there yet. That's kind of, especially in the space that we're talking about. I know in a lot of the other smart building spaces, we may be a little bit closer. I'd argue we got a long run to walk down to get to where we need to be in the refrigeration HVAC industry. And that's why it's so important that everyone, regardless of their backgrounds, start to come in and think about how we can solve this problem. And it's not just, responsibility of, in my mind, the OEMs in the HVAC space or the existing service technicians. It's folks that are thinking about smart building technologies and AI and ML and things that, are far outside of my expertise that can be deployed in this space to not only help solve climate crisis, but get to the grittiness of the issue, which is we need folks that just can better service these pieces of equipment so that these gases don't end up in the atmosphere in the first place.
Totally. Yeah. This whole time I've been just thinking about all the opportunities here. You could say we have a long way to go, which is true. But there's just a ton of opportunity for people to come in and solve problems here in this space. Let's close out, Tristam, with some carve-outs. So is there any books or podcasts or other sort of links we can share with the audience that have had a major impact on you lately?
Yeah, it's a great question. I guess I'll end by saying, part of the urgency for me is I have a 5-year-old and a 6-month-old, and I've been working in this space long before I ever had kids. But I think the joke there is I read a lot of Dr. Seuss these days, and my son happens to be obsessed with the Lorax, which is a good thing. So if the kids themselves aren't an important reminder of the urgency of addressing like the climate crisis, certainly the Lorax is a good secondary reminder as well. But more on topic, I'm constantly looking and hunting for new information. It's in part how I came onto your podcast, which again, I really appreciate you having me on today. But I definitely encourage some folks to go and read the recent heat pump report that was issued by IEA. It's a very, very long document, but I think it's important. Good news is there's finally mention of refrigerants, maybe not as much mention as I would like or we would like, but at least they're mentioned in there. So that's one. The other is, I don't know that I started off with, kind of the high level facts around refrigerants. So if you waited to the end and just started listening now, refrigerants are recognized as a 0.5 degrees Celsius opportunity. And if you total that up across refrigerant management and alternative refrigerants, the estimation is it's a 200 billion ton opportunity that we need to face into. On life cycle refrigerant management, one interesting report that was recently issued by EIA, NRDC, and IGSD, I mentioned earlier, it's called the 90 billion ton opportunity, is definitely worth a read, even if you just read the synopsis or the blog reports that were put out on it. Very interesting. I think the other thing that's caught my attention, and not to take a dark turn by any means, is the great filter theory that was outlined by NASA here recently, I think in the last month or so, about why we haven't interacted with other intelligent life forms. And effectively, the theory that they've come out with is that other intelligent life forms have effectively faced into catastrophic events, i.e. things like climate change that have wiped them off their respective planets. So not, like I said, don't want to take a dark turn, but I think the really thing that's attracted me to that is the issues that we're facing into are solvable. We just need to put more attention on them. And I am 100% optimistic that we have the ingenuity and culture and values that we can shift to and start to not only deploy the technologies, but one of the younger speakers at Verge, and I'm going to forget her name, so forgive me, but she said something that was really interesting to me. She said, it's not that we don't have the technologies, it's that we don't have the willingness to shift the culture and the paradigm to meet the demands to address the climate crisis that we're all facing into. So, it's both a cultural shift and it's a technology shift, and I'm optimistic we can do it. And, the great news is like I said, refrigerants, lesser known, but are still a huge opportunity, and there are solutions out there. Like I said, 0.5 degrees Celsius opportunity by the end of the century. If we start focusing on refrigerant management, if we start focusing on alternative refrigerants, and again, we're going to face into technology issues, but bringing the ingenuity together to do that, we have a real opportunity to solve the problem.
Amazing. Yeah, so super, super inspiring. I'll share a couple of Carveouts as well, so I don't always share on every episode.
I love it. I love to hear it.
I've run out of them. One is a book called After Cooling. I don't know if you've read this.
I've heard of it. I've not read it, though.
The author's Eric Dean Wilson. It's about 400 pages. I'm about 25% of the way through, but it breaks down a lot around this refrigerant problem, and it's actually where it starts. So it's the part that I have read so far, going through the history that you talked about. So for anyone that wants to go deeper into that, After Cooling would be a good book to read. I'll probably finish it over Christmas whenever I take a few weeks off. And that's my other Carveout as well. It's what I like to do in the last few weeks of the year. I've done this every year since starting Nexus, where I take a few weeks off and I pick one or two topics to go deep into.
Mm-hmm.
And I think what I'm going to do this year is I'm just blown away by this Chat GPT AI thing that has, kind of taken the world by storm in the last few weeks. I'm fascinated. Everyone should check it out. I'm fascinated for obvious reasons, which is I make my living educating and blogging and producing content. And you can literally, like today I did a prompt around, write me a blog post on the merits of the independent data layer for smart buildings. And it just popped out 5 paragraphs that were they were great. They were amazing. They were cutting edge. They were innovative. But it was a good summary of probably what's on the internet about that acronym that many people give me credit for making up. It kind of sounded like I was writing it a little bit, right?
So you may have teams. You may have.
Super fascinating.
Yeah.
Everyone should go check it out. It's got me wondering, okay, what are the unique things that I bring? What are the unique things that Nexus brings in terms of creating content? In a world where you can just type a prompt like that and get an entire blog post in 10 seconds.
Yeah.
So
it's
fascinating stuff going on.
It is extremely fascinating. Extremely fascinating.
Well, Tristam, thanks so much for coming on the show. This has been super interesting, a little bit depressing, but also inspiring at the same time. So appreciate it.
Yeah, my pleasure. Thanks so much for having me, James.
All right, friends, thanks for listening to this episode of the Nexus Podcast. For more episodes like this and to get the weekly Nexus newsletter, which, by the way, readers have said is the best way to stay up to date on the future of the smart buildings industry, please subscribe at nexuslabs.online. You can find the show notes for this conversation there as well. Have a great day.